Hello dear friends, welcome back to Math with Amala. This is the part number 9 of grade 12 chapter 1 Relations and Functions. Here we are dealing with the composition of functions and invertible functions. So what do you mean by composition of functions? As the name indicates, it's a kind of composition that we are connecting from one set to another. Let's take three sets A, B and C and define two functions f and g, and you will get one more function g composition f, that is the composition of these g and f. This f is defined from A to B, g is from B to C, then g composition f is defined from A to C. The element x of A can be connected to B with f of x, and element of B f of x can be connected to C with g of f of x. Then you will get g composition f from A to C such that g composition f of x is equal to g of f of x. You have to note that how that composition became an O function. Then for every x belongs to A, you can write g composition f of x is equal to g of f of x. Now if we take any element x from A, then f of x can be taken and also g of f of x can also be taken. This is the composition of functions. Here we are composing one or two functions together in order to get a new function, and we will deal with the examples in the next part. The next is invertible function. Inverse, we have already discussed with the inverse function. The same thing comes here also. Let's take f from x to y and a g from y to x. So here itself you are familiar with the inverse. You are taking the inverse from a y to x. Then you can have f from the domain x towards the codomain y and g from codomain y to domain x. Okay, so if we take f of x, it will be there in y and its inverse can be taken towards the capital X. Such that we are taking two functions here such that g composition f is equal to ix, I capital X. G composition f is equal to I capital X and f composition g is equal to I capital Y. What is ix and iy? These are the identities that we are taking for these particular functions. Ix is the identity in the x domain and iy is the identity in the y domain, y codomain. Okay, now you can write the inverse of f as g or f inverse equal to g. Okay, g as the inverse of f and it can be written like f inverse. G is f inverse. Hence the inverse function of f is g, and in return you can say it like inverse function of g is f. Okay, you can write f is equal to g inverse and g is equal to f inverse. Now let's have some properties of this invertible functions. When two functions are invertible to each other, or one function is invertible of another, inverse of another function, you can write if that function is 1, 1 and invertible, then it will be automatically onto also. Likewise, if it is onto and invertible, then it will be 1, 1. So it is a to and fro condition, or it's a necessary and sufficient condition. Also, if f is 1, 1 and onto, which means 1, 1 implies ontoness and onto implies 1, 1ness, then it is invertible. Hence, it is clear that when it is an invertible function, the 1, 1 ontoness comes like a necessary and sufficient condition. Thank you all for watching the video. Please be stay tuned for the next part which contains the examples of these last portions.